Welcome to section 3.4. This section is continuing our discussions about rates of change. We're going to be focusing pretty intently on the instantaneous, and here just reviewing all of our different names. And we'll talk a bit about motion, we'll talk about economics, we'll talk about even some geometry applications with this. But what this video is going to focus on is motion along the line, so either it's linear, so we're moving, say, left and right or up and down. And just some review of vocabulary with this. When we talk about displacement, we're talking about change in position. It's not the same as distance. Distance doesn't care about the direction you go. It's just how far you ended up traveling. So, for example, driving from my house to school is 14 miles, and then back to home is another 14 miles. So the distance I drive through in the course of a day is 28 miles. But at the end of the day, my displacement is 0 because I ended up where I started. We typically use an S for displacement, and I'll be honest, I'm not sure why. Well, then average velocity is what you're used to from science, with change in displacement over change in time. But when we want to find instantaneous velocity, that's going to be the derivative of displacement. So it's the instantaneous rate of change of displacement. And you'll hear instantaneous rate of change a lot with the discussions in this section. Velocity could be positive or negative. So when we actually speak about speed, it is the absolute value of our velocity. So if we want average speed, it's the absolute value of the change in displacement over change in time. Instantaneous speed is the absolute value of the derivative of displacement. Well, then we have acceleration. So acceleration is the rate of change of velocity. So if we're talking instantaneous, that'll be the first derivative of velocity. But since velocity is the first derivative of displacement, then acceleration is also the second derivative of displacement. Well, then we have jerk, and jerk is the rate of change of acceleration. And this is actually used correctly when you think of riding a roller coaster. So say you rode the Beast at Kings Island, and you get off and say, wow, that really jerked my head around. Well, that's using it correctly because the jerking of your head around is caused by changes in acceleration. So acceleration is the first derivative, or I'm sorry, jerk is the first derivative of acceleration, but since acceleration is the derivative of velocity, jerk is the second derivative of velocity, but since velocity is the derivative of displacement, jerk is also the third derivative of displacement.